Question 9, Part B. A pen moves along the x-axis, ruling a line. The diagram shows the graph of the velocity of the tip of the pen as a function of time. The velocity in centimeters per second is given by the equation v equals 4t cubed minus 24t squared plus 20t, where t is the time in seconds. When t equals 0, the tip of the pen is at x equals 3. That is, the tip is initially 3 centimeters to the right of the origin. Part 1. Find an expression for x, the position of the tip of the pen, as a function of time. To find an expression for the displacement or the position of the pen, which is represented by the variable x, we integrate the expression for the velocity v with respect to t. Now v is given as 4t cubed minus 24t squared plus 20t. So integrating this expression with respect to t, we get x equals t to the power of 4 minus 8t cubed plus 10t squared plus the constant of integration c, which we'll need to find using an initial condition or a boundary condition. Now it's given that when t is equal to 0, x is equal to 3. So substituting 0 for t here, here, and here, we get 3 is equal to 0 plus c, which means that c is equal to 3. So putting that all together, we get x is equal to t to the power of 4 minus 8t cubed plus 10t squared plus 3. Part 2. What feature would the graph of x as a function of t have at t equals 1? At time t equals 1, the velocity of the pen is equal to 0 because that's where the graph crosses the horizontal axis. And this implies that dx dt, which is the rate of change of the position of the pen with respect to time, is equal to 0. So this means there'll be a stationary point on the graph of y equals x of t at time t equals 1. Now, before time t equals 1, the velocity of the pen is positive because the graph is above the horizontal axis. And after time t equals 1, the velocity is negative because that part of the graph is below the horizontal axis. Therefore, the stationary point where t is equal to 1 will be a local maximum. Part 3. The pen uses 0.05 milligrams of ink per centimeter travelled. How much ink is used between t equals 0 and t equals 2? Since the pen changes direction at time t equals 1, to find the total distance, we integrate v with respect to t from t equals 0 to t equals 1, and then we add on to that the integral of v with respect to t from t equals 1 to t equals 2. And to ensure that both of these integrals result in a value that's greater than or equal to 0, in other words, ensuring that we don't get a negative value, we put absolute value brackets around each of these integral expressions. Now, if we're working out displacement, we won't need these absolute value brackets. But because we're working out total distance, whether the pen is moving forwards or backwards, it doesn't matter. So it's a bit like the odometer of a car. So it doesn't matter which direction the car travels, the odometer always moves forwards. Now we can use the expression for displacement from part 1. So since we've integrated v with respect to t already, the integral of v with respect to t is t to the power of 4 minus 8t cubed plus 10t squared plus 3. And we're evaluating this expression from t equals 0 to t equals 1. And we'll put absolute value brackets around that to ensure that it's a positive value or a non-negative value. And we're going to add on to that t to the power of 4 minus 8t cubed plus 10t squared plus 3 from t equals 1 to t equals 2. And we'll put absolute value brackets around that expression as well. So applying the limits of integration, we get the absolute value of 6 minus 3 plus the absolute value of negative 5 minus 6. Now the absolute value of 6 minus 3 is 3, and the absolute value of negative 5 minus 6 is positive 11. So 3 plus 11 gives us 14, and that represents the total distance travelled by the pen from t equals 0 to t equals 2. So to find the mass of ink used, the pen travels 14 centimeters and it uses 0.05 milligrams of ink per centimeter, and that gives us 0.7 milligrams of ink used.